it reads the destination MAC. If it knows it, it immediately forward. As you see here, store and forward has two characteristics. The first one is the error checking. The switch will check for the errors using CRC errors, for example. And if the switch finds too much errors or some bad frames, I mean, these frames will be discarded by the switch. And second thing, imagine if we are talking about receiving frames, the entire frames. So we should receive, or we should have buffers between, because imagine the incoming frames from the ingress port and the egress port. And in between, we should have buffer to hold the incoming. So if the incoming ports have higher speed or have a significant important speed than the egress, congestion will be happen. This is why we have buffering. So the ingress interface incoming here, for example, will buffer the frame. So we'll have buffer to receive this from the ingress interface, while the switch checks the FCS, frame check sequence. This also allows the switch to balance between the speeds. This buffer will help switch to balance between the ingress and our egress ports to avoid congestion. While as cut-through switching, as you see here, you see here, store and forward switching entails receipt of the entire frame up to, wow, 9,200 bytes for jump of frames before a forwarding decision is made. So it's large frame, 9,200. However, here, as you see, we only need to check this small part. So frames can begin to be forwarded as soon as the MAC is received. As far as we know this MAC, we forward the frame without checking all these things. Okay? So cut through forwards the frame immediately after knowing or determining the destination MAC. So this is in 64 bytes, for example. So fragment-free method will check the destination and ensure the frame is at least 64 bytes. This will eliminate runs. What are runs? Runs that are the frames with less than 64 bytes. They have frame size less than 64. Okay? So we need to check at least 64 in order to determine the MAC destination. So the good thing for this method of which we call cut-through switching, it's good for switches needing small latency under 10 milliseconds, and for communication frames that doesn't need error check. Okay, and this can help to bandwidth problems. Why? Because we may propagate too much errors. Okay. Now switching domain, two types. What's the switching domains? And we will talk first about collision domains. As you know, in full duplex here, for example, we don't have collisions. So all collisions are eliminated in full duplex. So switch eliminate collision domain and reduce congestion. When there's a full duplex on the link, collisions are eliminated. This is for sure. However, when there are many two half duplex, one or more devices that work in half duplex, what does this mean? It means that we will have collision. Why? Because we are sharing. We will contend. We will be sharing the communication links, right? So we will wait other, for example, uh, other connections or transmissions to be done. If they are over, we will should start our transmission. So we should to wait, right? So when there's one or more devices in half duplex, it means that you can't receive and send at the same time. So you will send, then you will wait to receive, right? So when there's one or more devices in half duplex, there will now be a collision domain. There will now be contention منافسة for the bandwidth. As I told you, you should wait your turn to transmit. So we can have collisions. In Cisco or Microsoft, all the most of the devices they use we have learned about it, the auto negotiation service, which use the duplex, which sets the duplex and the speed for each communication. Okay, link. We have learned at the first lecture, I guess. Here, collision domain, when we will use, as I told you, collision domain comes from using half duplex. For the full duplex, we don't have. Okay, broadcast domain, what does this mean? Broadcast domain, can be done or can be achieved on using layer 1 or layer 2 on a LAN, for example. But for layer 2, we will not have this broadcast domain. Okay, or MAC broadcast domain at least. Okay, so what does this mean? The broadcast domain. The broadcast domain, it means that whenever all these devices, PCs, or receive broadcast messages on this LAN, for example, from this switch, we call this broadcast domain. Okay. But sometimes if you link many LANs together and you start to have some broadcast domain, this will create congestion in the network. So in the broadcast domain, you should, as I already mentioned it, okay. Whenever you want to broadcast, you shouldn't broadcast, or the switch doesn't broadcast the message through the port that it has received from. So he will broadcast the message on all ports except the ingress port that it has received the message from here, except for the ingress interface. If we do here many broadcasts, we will have, as I told you, network problems, such congestion, for example. So here the broadcast can be done at layer 1 and 2. If we increase the number of devices, we'll have more difficulties while using broadcasting because we will face congestion and network problems, performance problems. And whenever we broadcast, we don't broadcast the message at the same ingress port where we have received the frame from. How we can decrease or alleviate or reduce the network congestion. So basically, in order to do alleviation or to alleviate, نخفف, to reduce these conjunction, we can use switches that use full duplex. As you see, full duplex uh, don't have collisions. So we will use full duplex. We encourage switches to use, or we use switches that use full duplex settings to eliminate collisions and divide or to avoid these congestions. So how we can alleviate? We can use these protocols or choices in order to decrease the or to alleviate the congestion. For example, we use high speed ports. Okay, so we encourage the switches that use high speed ports starting from, for example, 100 gigabit per second speeds, because whenever if it's a very speed, you will not have congestions. And we can use inside the port internal buses to improve the performance, because internal buses they make the communication internally very fast, and we use shared memory instead of accessing another memory. Okay, so we use shared memory to improve performance. And also we can also provide switches that have many ports to connected LANs. Okay, this also reduce the congestion if we use several or more or many ports to be connected to the LAN. Why? Because if we have many LANs, we don't need to wait some ports to be free. For example, we send on all ports and all messages will be transmitted in all ports. So no messages can wait, or no frames can wait to be transmitted in the next step. For sure, we also use large buffers. We forget it. Here we can use large buffer. Why? Because to save to store or to record